For our first example, we want to solve the equation 5 cosine x equals 3 cosine x plus root 3. So with this, what we want to do is take our terms here and just isolate the cosines. We're going to pull this away, and we're going to take that 5 cosine x, 3 cosine x plus square root of 3, and we're going to get all of the cosines on one side by subtracting 3 of them from each side. Subtract 3 cosine from here, goes away, while on the left side, we will have 5 minus 3, or 2 cosine x, and that's just equal to root 3. And then from there, we can divide out the 2, and we'll have cosine x equals root 3 over 2. And this is usually our goal with this kind of problem, is to take whatever pieces we have and try to get things in terms of just a trig equation, a trig expression, that is. And be careful about that. A trig expression equaling some number, or maybe an expression with a constant tacked on somewhere, but something that's just one or two terms equaling a constant value. Where here, our goal is to find the values x that satisfy this. That is, we want to find the values x, the angles for which cosine is root 3 over 2. So, obvious candidate, should be obvious at this point, maybe it's not, I'm still working through this stuff, is pi over 6. But that's not the only one that we can get. We also have, if we come all the way back around into the fourth quadrant, 11 pi over 6. And then if we go back into the first quadrant again after a full rotation, 13 pi over 6. And a whole lot more. We can go to quite a few lengths with this. If you want to get a general solution here, and general solutions are what we use to refer to things where we have a class of potential answers. The two forms that we can have here, and we can rearrange this a little bit to make it a bit cleaner in terms of just one form, but two's easier to see in this case. We could write it as pi over 6 plus 2n pi, or 11 pi over 6 plus 2n pi. That is, we're either looking at the one just above or just below the positive x-axis, where we're taking numbers of rotations all the way back around to end up in that same place. These are the potential values that we can have for x. They follow one of those two patterns. Again, you can condense down to one, but it's easier to say it like that. Anyway, this is clunky. So we don't normally write things in this way. More often what we'll do is restrict it down to the domain from 0, including 0, to 2 pi, but excluding 2 pi. Why we do it this way in particular? No good reason except that usually 0 to 2 pi is a good single period of most of them, and we don't want to start exactly where we end, because we like a, at least kind of one-to-one things. Not really, but, well, we just like to make that restriction. In any case, if we specifically look there, we have that x is either pi over 6 or 11 pi over 6. And this is the type of thing we're going to be doing a lot. We're going to be taking some pieces of these forms, stick them together as best we can, and then find where they fit on that first run of the unit circle. Anyway, from here, we're going to take another example. We're going to look at this in terms of multiple angles.